Hello students, so welcome to the last part of the lecture series on the previous year GATE questions on the topic of basic concepts in network theory. So this is the last part of the lecture series. So let's come to the question. So here it is given that there are three capacitances connected as shown in the figure. Okay, so let us say that the voltage across this is V. Okay, so it is given that this is 10 microfarad, this is C1, this is 5 microfarad, this is C2, and this is 2 microfarad, this is C3. Okay, so it is given that the voltage across the breakdown voltage of the capacitances are 10, 5 and 2. So the breakdown voltage is 10 volt, 5 volt and 2 volts. Okay, now what can be the maximum safe voltage that can be applied across the combination? So we have to find the maximum value of V so that no capacitance break down. Okay, so let us say this is VC2, this is VC1, and this is VC3, and this is VC1. So we can say that VC1 is equal to V. So so that C1 breakdown, the C1 capacitance does not break down, so V should be less than 10 volt. This is condition number 1. Now VC2, now the voltage division rule between C2 and C3 is VC2 is equals to 2 upon 2 plus 5 into V. Okay, so as we know that VC2 should be less than 5 volt, so 2 upon 7 V should be less than 5. This is condition number 2. So V should be less than 35 by 2. Okay, this is condition number 2. Now VC3 is equals to 5 upon 2 plus 5 V, and since VC3 should be less than 2 volts, so 5 upon 7 V should be less than 2 volts. So V should be less than 14 divided by 5. This is condition number 3. So from the three conditions, this is condition number 1, this is condition number 2, and this is condition number 3. We can get that V should be less than 14 by 5 because this is the minimum value. Okay, this is 10, this will come out to be 17.5, and this will come out to be 2.8. So V max is equal to 2.8 volts, so that these devices or these capacitances does not break down. Okay, now the another part of the question is we have to find the total charge in microcoulombs. So since we know that total charge Q equals to C into V, so Q total is equals to C effective into V. Okay, so we know that the voltage applied is 2.8 volts. We will find the effective capacitance or the total capacitance of the circuit. So this is 10 microfarad, this is 5 microfarad, 2 microfarad. Since these two capacitances are connected in series, so their equivalent will be 5 into 2 divided by 5 plus 2 microfarad in parallel with 10 microfarad.